In this video, we'll see how to solve examples on balancing of rotating masses. So let us start with the problem statement. A line shaft carries 5 pulleys P, Q, R, S and T which are equally spaced along the shaft. The masses of pulleys P, R and S are given as 10 kg, 8 kg and 16 kg. The masses of Q and T we have to calculate and their angular position also. The eccentricity or radius of all the pulley masses can be assumed equal. Now the angle between P and R is 90 degree and between R and S is 135 degree measured in the same direction. Find the masses of pulleys Q and T, that is MQ and MT we have to find out, and their angular position, that is theta Q and theta T we have to find out, such that the shaft is completely balanced. So this is known as the longitudinal view and this is known as the end view. This is the line representation of the shaft and the direction of rotation. So omega is the angular speed of the shaft, r is the radius of the masses, mass P is of 10 kg, mq we have to calculate, r is having mass of 8 kg, s is having mass of 16 kg and T is having mass of mt. So mq and mt, which are represented in red, those masses we have to find out. Suppose we take this as our reference plane, then distance to the left of the reference plane, they are considered as negative. So you can say that the P is having the distance of minus L because it is on the left hand side of this particular reference plane. Now reference plane we have to choose in such a way that, so the plane which is having maximum unknown we can consider as the reference plane. So here reference plane we have considered as Q because mq, that is mass Q, is unknown and theta Q is unknown. You can choose this T also, but to the left of the T all the distances will be negative and therefore maximum negatives will be there, and therefore I have considered this as the reference plane. So Q is considered as the reference plane which is having two unknowns mq and theta Q. So P will have reference according to the reference plane, it will have a distance of minus L, R will be at a distance of L from Q, S will be at a distance of L plus L, that is 2L from this reference, then T will have L plus L plus L, that is 3L distance from this reference plane, and Q will have distance from its own as 0. So let us formulate the table for this. So before we go to the table, let us see the concept of centrifugal force, which is mass into centripetal acceleration. So it is mr omega square. Now in this particular case, r is given as same and omega rotational speed of the shaft is also same. So we can say that centrifugal force is directly proportional to m and the mass is in kg. So whatever the value that will initially get will be in kg for the centrifugal force. And if you know r and omega and multiply by r omega square, that is the centripetal acceleration, then you will get the centrifugal force in Newton. So couple is force multiplied by distance. So Fc is mr omega square. Again, r and omega, they are constant. So we can say that couple is directly proportional to the product of ml, and mass is in kg and L, that is the distance, is in meter. So couple will be having unit of kg meter. And if you want in Newton meter, then you have to multiply it by r omega square, as we have discussed in our centrifugal or centripetal force also. Now this table is very important. So here this is the reference plane, and as we have discussed earlier, the various planes first we have to write down, that is P, Q, R, S and T. As this is the reference plane, its distance will be 0. So start with this. P is on the left hand side of Q, so its distance is minus L, which we have already seen. R is on the right hand side of Q, so it will be positive L. S, as we have seen earlier, it is 2L, and T will be at a distance of 3L. Now F is proportional to M, so masses of mass MP is given as 10, MQ we have to find out, R mass MR is 8 kg, mass of this particular mass S is 16 kg, MT we have to find out. These are the calculated values which are represented by this particular circle, or you can say ellipse over here. So these are the values which we have calculated from the diagrams. So from the graphical way or graphical method. So MT is still unknown. So MQ and MT are unknown. Force is directly proportional to M. So whatever is the mass M, the same will be the force in kg. So it is 10 kg, then MQ kg, 8 kg as it is, 16 kg as it is, and MT as it is. Distances already we have seen. Now couple is proportional to M multiplied by L. So it is the product of these two columns. So 10 into minus L, that is minus 10L. MQ multiplied by 0, that is 0. 8 multiplied by L, that is 8L. 16 into 2L, that is 32L. This is mass is MT and this is 3L. So it is 3MTL which we have to calculate. So the things which we have to calculate are circled over here like this. Now the important part is that of the angular distances or angles. So suppose we assume P as the reference, suppose it is coinciding with the positive x-axis, so it is 0 degree. Theta q we have to find out. Angle between P and R, the planes P and R, the angle is given as 90 degree. Between R and S, the angle that is given is 135 degree. So from P, we are measuring the angle that is from positive x-axis. So it is 90 plus 135. So total angle will be 225 degree from plane P. And theta T obviously we have to calculate. These are the calculated values which I have shown over here, 24 degree and 12 degree. Those we will get from the diagram. Now always concentrate on these two columns before we draw the diagram, that is force column and this couple column. So in the couple column there is only one unknown, that is 3 empty L. Correct? Don't consider this L as the unknown for the time being. So suppose it is minus 10, 0, 8, 32 and 3 empty. So it is having only one unknown. Whereas in case of the force column, we are having MQ and MT as two unknowns. So we have to draw first the diagram which is having lesser amount of the what we can say unknowns. So this is having less unknowns, that is only 3 empty L is there. So we'll start with the couple polygon scale. So assume the scale. Now depending upon these values, that is 10, 8, 32, we have considered the scale as 1 centimeter is equal to 4L. Now we have taken into consideration this L also in our scale so that there will not be any problem. So this is very, very important. So let us see. 1 centimeter is representing 4L kg meter. The unit of couple is kg meter. Then minus 10L will represent how many centimeters? So that will be minus 10L multiplied by 1. So just cross multiply by these two terms divided by 4L. So L will get cancelled. Minus 10 divided by 4, that is minus 2.5 centimeters. So we can say that minus 10L will be represented by minus 2.5 centimeter on our couple polygon. Now negative sign indicates that its direction will be towards the center. So negative couples are always directed towards the center. The second one is 0, then 8L. So suppose say 1 centimeter is 4L kg meter, that is our scale. So 1 centimeter represents 4L that we have taken from this. You can assume any scale, not necessary 4. It will be easy because 8 divided by 4 is 2, 32 divided by 4 is 8, 10 divided by 4 is 2.5 and so on. Therefore, we have taken this 4L as our scale. So 1 centimeter represents 4L. Then 8L will represent how many centimeters? So it will be again cross multiply by this 8L to this 1 divided by 4L. So this L will get cancelled. 8 by 4, that is 2 centimeter. So on our diagram, we are going to represent this 8L by how many centimeters? 2 centimeters. Then similarly, the remaining one is 32L. So that also we'll see. So 1 centimeter represents 4L according to our scale. Then 32L will be representing how many centimeters? So it will be 32L multiplied by 1 divided by 4L. Again, L will get cancelled out. So 32 divided by 4, that is 8 centimeter. So we can say that this minus 10L will be representing minus 2.5 centimeter. Then 8L will be representing 2 centimeter. 32L will be representing 8 centimeter. And this is the unknown which we have to calculate from the diagram. So let us draw the diagram now. So as we have considered P, which is coinciding with the positive x-axis, so it is represented over here by considering any radius r, because r is arbitrary over here, but it is constant. So you can draw a circle of say 3 centimeter, 2 centimeter, 4 centimeter, whatever it may be. Then consider this P along the positive x-axis. So its angle is 0, that we have indicated in the table. Angle between P and R is 90 degree. Then angle between R and S is 135 degree. Now as the couple for first plane P is negative, therefore it will be directed towards center. So this arrow indicates that it is a negative couple which is directed towards O. Then all the other couples, they are positive, so they are directing away from the center. So that is just indicated over here for the better understanding purpose. So first we have to take into consideration 2.5. So this is 2.5. Now I am not talking about negative sign because we have already considered that negative sign in the direction which is directing towards the center O. So this is this O and this O, they are different. This is just the starting point, that is O. This is the center of this particular diagram. So we have to consider the first couple, which is negative couple, directed towards the center O from any particular point. So you can consider any other point over here, A, B, C, etc. I have just considered it as O. So this is the starting point which will be directed towards this center. Then, and its length is 2.5, that we have already seen. Then this is the couple of R, which is of 2 centimeter. Again, it is radially outward because it is positive couple. Then S, which is of 8 centimeter, that is drawn from this. And then you will get the closing side, and that closing side is nothing but what? It is the unknown, that is 3mtl, that we have already seen in our table. So this 3mtl will be equal to this length CO multiplied by scale. So length CO is how much? You have to measure this particular by the scale, and it will be 9 centimeter multiplied by scale, that is 4L. So this L will get cancelled. So you'll get 3mt is equal to 9 multiplied by 4, that is 36. So mt will be equal to 36 divided by 3, that is 12 kg. Now draw a line parallel to this line from O. So you'll get the location, angular position of mass T, because mt is there. So it is the mass of T, mt is under plane T is under consideration, and its location is at a distance of 24 degree. So these two values now we know, that is mt is equal to 12 kg. Each diagram, that is couple polygon or force polygon, they will give you two unknowns always, correct? So mt is now 12 kg. So we can say that this mt now we have mentioned over here. So as it is 12 kg, force is also 12 kg, and theta t is 24 degree. So these two values are now known to us, mass and angular position of T. So this already we have seen. Now we'll go to the another polygon, that is the force polygon. So here now we know the value of mt, only unknown is now mq and theta q. So in the force polygon column, we are having only one unknown. Mass of P is known to us, mass mr is known to us, ms is known to us, correct? Mass which is mounted in plane S. Now mass in plane T is having mass of 12 kg. So again we can take 1 centimeter is equal to 4 kg, because 4 is the multiple of this 8, 16, 10. You can easily get the values over here. So 1 centimeter is equal to 4 kg, then 10 kg will represent how many centimeters. So cross multiply this. So it will be 10 into 1 divided by 4, that is 2.5 centimeter. So on our force polygon, this will represent 2.5 centimeter. This is unknown. So let us consider this 8 kg mass. So again, 1 centimeter represents 4 kg. You can assume any value over here. Then 8 kg will represent how many centimeter? Again, cross multiply by this. So 8 into 1 divided by 4, that is 2 centimeter. So on our graph paper or on our graphical sheet, we are having drawing sheet, we are having this 8 centimeter represented by 2 centimeter. Similarly, if 1 centimeter represents 4 kg, then 16 kg will be representing how many centimeters? That is 16 into 1 divided by 4, that is 4 centimeter. So this 16 kg will be representing 4 centimeter on our drawing sheet. Now mt is now known to us, it is 12 kg. So 1 centimeter represents 4 kg according to our scale. So scale is 4 kg. Force polygon scale is 1 centimeter is equal to 4 kg. So this value we have to use in the calculation. So 1 centimeter represents 4 kg, then 12 kg will represent how many centimeters? So cross multiply by this. So 12 into 1 divided by 4, that is 3 centimeter. So 12 kg is representing 3 centimeter on the drawing paper. Now start with the point O. Now these are the things which are known to us. So we'll start with P, R, S and T. So according to the planes which are given in our table. So first one is that of P. Now always remember that forces, they are centrifugal force, it will always act radially in the outward direction. So all the vectors, force vectors will be radially outward, whereas in case of the couple, negative couple vectors will be towards O, all the other positive couple vectors will be away from O. So here all the vectors will be away from O, because according to the definition of the centrifugal force, the force which is acting away from the center is known as the centrifugal force. So this is the first vector, as you can see, and what is its length, that we have already seen in our it will be how much? 10 divided by 4. So that will be the length of that particular vector. Then next one will be R, that is represented by this A, B. Then the next one will be of this blue line representing the mass in the plane S, centrifugal force in this particular plane under consideration. Then for this T, which is represented by this green line, so green vector we will draw over here, and then we'll close this diagram. So all these values which we have taken into consideration. So this is 2.5, this is 2, this is 4 and this is 3. So all these things we have considered in this diagram, that is 2.5, then 2, then 4 and then 3 centimeter, and then the closing side. The closing side will be nothing but it will be the unknown mass, that is mq. So this is our mq. So first we'll see this, the mq is nothing but what? Length do. So let us once again try to understand how we have drawn this diagram. So first draw this vector, first vector, radially outward. Forces are radially outward by 2.5 centimeter, representing the force on mass, centrifugal force on mass, which is there in plane P. Then next one will be for R, 2 centimeter. So AB represents centrifugal force in on mass R in which is there in plane R. Then this mass under consideration in plane S by 4 centimeter. Then the mass under consideration in plane T, which is of 3 centimeters. So length CD will be of 3 centimeters. So OA 2.5 centimeter, AB 2 centimeter, then this particular vector 4 centimeter, and then CD will be of 3 centimeter as per the calculations which we have done in the tabular form, and then close it. So and then draw a line parallel to this particular vector from O, so that it will give the mass of Q. And if you measure this angle from positive x-axis, this total angle will be 190 degree. So now length, this particular length OD will be representing, or DO will be representing mass MQ, which is unknown. So measure this length DO, it is 2.48, multiply by the scale is 4 kg, as we have seen 1 centimeter is equal to 4 kg, so scale is 4 kg, so it is 9.92 kg. So in this way we can find out the unknown masses to balance the given particular rotating system.